The last two calculations we need to make in preparation for making our oscillating reaction is to figure out what to do about solution 3, and then also to make a calculation to figure out what I did to prepare the starch solution. You're not going to have to prepare your own starch solution because this one in and of itself takes a couple of hours to prepare. But I do want you to think about what I did as I made the starch solution for you. Solution number 3 calls for a 3.6 molar solution of hydrogen peroxide. But we're going to start with a 30% by weight solution of hydrogen peroxide. Now, part of this is somewhat similar to what you did with the sulfuric acid. You started with a concentrated solution and you added water until you had 25 milliliters of a more dilute solution. The hydrogen peroxide is going to work very, very similarly, except that in this case, the unit systems on the two concentrations don't match. Your concentrated solution is going to start given us percent by weight, and the solution you want to produce is going to have units of molarity. We're going to need to use the C1V1 equals C2V2 dilution equation, but before we can start, we have to figure out what this 30% by weight means, and then also think about how we can get that 30% into molarity so that we can make a reasonable comparison with this 3.6 molarity. When we talk about the starch solution, we have another percent problem here, and that is that I need 300 milliliters of a 3.0 weight volume percent solution. Both of these situations are going to introduce the need for another set of concentration units. Page 6 of your notes has room for some other concentrations. The concentration that chemists use most often is molarity, moles of solute per liter of solution, and that's what you've been working with in the last day. The reason chemists work with molarity is that they're often concerned about how many solute particles are present in solution, and chemists count particles in terms of moles. The rest of the world, however, who aren't comfortable with chemistry, often think about things in terms of percentages. Concentration of solution can also be calculated as a percent concentration using the idea of part over whole. In the case of a solution, the part is the solute, the whole is the entire solution. So a percent solution is calculated by doing the amount of solute divided by the amount of solution multiplied by 100. There are really three different ways to do this. The first method is percent by mass or percent by weight. That's the 30% hydrogen peroxide solution that you're being given to start with in your oscillating reaction lab. To calculate the percent by weight, you simply take the mass of the solute, divide by the mass of the solution, and multiply by 100. It doesn't matter what units you have on the mass, as long as the mass of the solute and the mass of the solution are expressed in the same units. For small quantities of solutions, we will typically use grams of solute per grams of solution. The next possibility is a percent by volume. A familiar solution you might have around the house that's percent by volume would be your 70% solution of isopropyl alcohol, also called rubbing alcohol. Because isopropyl alcohol and the solution of isopropyl alcohol are both liquids, it seems convenient when making the solution to measure your solute in terms of volume and your total solution in terms of volume, simply because they're both liquids. Again, the units here aren't important as long as the volume units on solute and the volume units on solution are the same. For small quantities, again, we're typically going to use milliliters and milliliters for our solute and our solution. The last percent concentration is a unit of kind of convenience. We're very often mixing a solid solute into a liquid solution. It's often easiest to measure the amount of solid in terms of grams and the amount of solution in terms of milliliters, so chemists have invented the percent mass volume solution. This is like the starch solution that I have to make for you to use as the blue color in your oscillating reaction. Percent mass volume is always grams of solute per milliliter of solution multiplied by 100. It is important, however, that we can convert between our percent solutions and our molarities. With solution 3, we are starting with a 30% by mass solution of hydrogen peroxide. We need to dilute that to get a 3.6 molar solution of hydrogen peroxide. In order to convert between our percent by mass and our molarity, we're going to need the density of the solution, which you'll notice is given on your blue sheet with your recipe for your oscillator, as well as the molar mass of your solute. In this case, your solute is going to be H2O2, and calculating its molar mass involves using your periodic table. Before you tackle the last two calculations you need to make for your pre-lab, I'd like you to go back to your concentration practice problems and complete questions 7 through 10. These are questions that are going to give you some practice with your percent solution concentrations, and question 10 is going to give you some practice converting between percent solutions and molarity solutions and applying that situation to the dilution equation.